Okay, so we're going to be talking about mobile battery systems or battery trailers. So this is a business we kind of discovered early on, right after the formation of Mesa. We had a couple of customers come to us and say, hey, would you guys consider building us battery trailers? And we're like, nah, we don't do that. And then after about the third request, we realized, hey, there might be a business here. And we built our first trailer, learned a lot of lessons, and 20 years later, this is a very nice business for us. We do a lot of trailers every year, so I want to share with you some of the things we've learned over the years. So obviously, all of us here know that with mission-critical power systems, portable battery backup is a must. You know, anytime we're doing maintenance or we're replacing batteries for mission-critical applications, you got to have a source of backup power. And if anybody has ever dragged batteries and you know the typical portable power, it's a lot. There's a lot of logistics. The trailers make it easy to deploy rapidly, quickly, and safely. So, you know, one of our favorite quotes from one of the senior engineering managers, big substation outfit, he just saw battery trailers as being sort of the seamless interface between all of his maintenance requirements at the substation. And he just saw it as a critical tool for their arsenal. So you look at the use cases, you know, really any scenario where you have emergency power requirements, you know, certainly for communications. We have deployed trailers for sites that have gone down. Any kind of temporary power requirement, a lot of times there's special events. People are looking for power, being able to wheel that up and easily deploy. Really any situation that needs a quick, efficient, rapid way to provide the critical, you know, backup. And for the utilities, it was really important because in many cases prior to having something like this, they oftentimes would have to notify some of the regulatory groups and schedule an outage to do maintenance and installation of new equipment. The battery trailer eliminates the need for a lot of that regulatory notification. This was just kind of the business case that, you know, we realized early on, you know, without a battery trailer, there's a lot of expense. You know, every project involves bringing in equipment, notify the regulator, okay, if you're having to schedule an outage. You have to build a temporary power bank manually on site, all right? And there's just a lot involved with the logistics. You compare that to a battery trailer. Utilities, as we know, utilities love CapEx. So if they can eliminate many of the operational costs with a trailer that they buy through CapEx, that's a win for the utilities, all right? And trailers, you know, if you maintain them, we've got trailers that are almost 20 years old that are still in the field, still working. So it's a rugged, you know, long life solution to this problem of battery backup power. So a couple things we learned. When we started, we realized, hey, there's a business here. We early on did a traditional SWOT analysis, strengths, weaknesses, opportunities, threats, to evaluate the business opportunity. And one of the things we realized pretty quickly that one of our biggest competitors were going to be the end users themselves. Utilities were, you know, early on looking for ways to easily deploy, and we found that a lot of them they didn't have the budget to, you know, to do a industrial grade trailer. So they were trying to do skunk works designs with limited budget. Our approach was, hey guys, if you're going to do this, we think you need to use high quality, you know, trailer designs, okay, and build this thing right that will meet the fleet standards for many of these end users. One thing I've learned over the years with the utility fleet, don't get crosswise with them because they have very stringent requirements for what they're looking for in wheeled equipment. So we believe we use high quality frame trailer designs. We always recommend dual axle, heavy duty, type of axle construction. We see reinforced axle designs, the frame type trailers, okay, with reinforced floors, high quality, And the utilities and many of the other end users immediately saw the value of a higher grade trailer design, just in terms of life and the performance and reliability of those trailers. So each trailer is pretty unique. Every customer has a somewhat different use case, so they are highly customizable. Some people want more AC lighting. They want more AC distribution inside the trailer for all sorts of monitoring equipment. They tend to be a little bit unique, every trailer. So we do that. We build in the AC lighting. We build in the heating, the cooling. As you'll see, almost all of our trailers utilize industrial wheels, which makes it really convenient to not only store cables when you're in transit or it's in the yard, but to easily deploy those cables when you get on site. We'll show you some pictures of that. So just some of the features that we do about. Most of our users do want dual voltage outputs, so it'll be typically a 125 volt charger and then a 48 volt converter. For typical substation, for example, you've got 125 volt DC, you also got 48 volt for the communications. So we want to be able to accommodate both. Most of our trailers typically are 12 to 14 feet in length, and I'm sure you're very familiar, 7 feet wide, 10 feet in height, and that's a pretty typical design. We've done bigger trailers, we've done smaller, but that 12 to 14 is kind of typical for where we're at. And we talked about the cable reels. We learned it's really important to make sure you understand the use case for each trailer, because there's a lot of subtle differences in the use cases. Obviously, we typically recommend VRLA batteries for obvious reasons. Great power density, pretty rugged, non-spillable. Our early trailers were typically 200 amp hour. We're seeing now people are looking for 400, even 600 amp hour. So our recommendation is VRLA. We don't recommend, of course, flooded batteries. We have some users who insist they want NiCad batteries, so we don't argue with good customers. So we've done trailers with NiCads. And also a couple of our customers like those traditional railroad type batteries, so we've used those as well. But VRLA is the norm. We're seeing a lot of interest in higher capacity lithium battery trailers. We built our first prototype about 5 years ago with a 120 kilowatt lithium battery stack. Learned a lot on that one because lithium, introduces a whole new series of considerations involving DOT standards for the transportation of lithium batteries, the placarding, and with high capacity lithium batteries, now we're dealing with safety, placarding, arc flash. So it was a lot more complicated, and the prototype was used to evaluate lithium battery trailers. So we're seeing a lot of RFQs coming out, and there are some emerging global standards when you're transporting lithium batteries to limit the state of charge on those lithium batteries to 30% maximum. Anybody here in the lithium business is probably familiar with that. Almost always we recommend the use of switch mode chargers. We like the switch mode. It's lighter weight. They're easier to mount. They're easy to maintain. Rectifiers can be slid in and out very easily. So typically we'll have a 125 volt switch mode rectifier with a 48 volt converter for people looking for dual voltage. Of course, some of our customers want to mimic their own in-house substation standards, so we have certainly done a number of trailers with SCR type chargers, and we're happy to do it, just considerably heavier and larger. And balancing trailers, very important. We spend a lot of time trying to figure out, where to put the batteries, where to put the charger, where to mount all of the equipment, because we learned early on that an unbalanced trailer presents some real safety issues. So taking care to really try and even out the weight distribution of the trailers just makes a lot of sense. So These are two pictures of our typical trailer layouts. You can see here, these are the cable reels that we install. We typically will have one reel for the input shore power to power the trailer, and then we'll have dual cable feeds for the output power from the batteries. We include eyewash and a lot of the OSHA safety equipment with every trailer that we provide. You'll see inside, we'll show you some other pictures, but we've got AC panels, we've got overhead lighting, we've got outlets to accommodate all of the different customer use case requirements. And over there you'll see we've got disconnects, there's the switch mode charger mounted, and that's pretty typical. Another picture of the same deal. We try and keep, using seismic racks, keep those batteries as low to the floor as we can get it. Just to eliminate some of the sinusoidal loads and any unbalanced scenario. Yeah, so very important that we understand at the customer yard where the trailers are going to be stationed, making sure that we have planned for proper charge management of the trailer. And this is where sometimes customers don't realize how important it is. After every deployment, they bring this trailer back into the yard to make sure that they get these batteries on charge to keep them on float, especially if there are gaps in between deployments of the trailer. So typically, most of our customers ask us to provide a 2-pole split phase shore power input, 240 or 208 volt. That is typical of what we see with most certainly our utility customers and many of our industrial customers. Many customers are asking for remote communications, so they want to be monitoring the trailer, but they want to have access to the system. They want to be able to monitor the state of the battery, the state of the charger. So more and more of our trailer designs, we're incorporating GPS and antennas so that they can maintain communications with that trailer. With lithium-based trailers, it's absolutely critical. You can't operate, without constant communications with the battery. So typically, when the trailers come in, we recommend that the batteries be directly connected to a DC load board or DC bus at the site. To make it easy for our customers, we try and include always a connector or cable with connectors that have bare lead wire. We'll have connectorized version, and we'll have various pigtails to accommodate every connector configuration that we might run into at a customer yard or a customer site. Some of the other equipment that is typically found, that's a 125 volt switch mode rectifier to the right. Very rugged design that works very well for our trailers. And you'll see we've got AC panels, we've got dual disconnects for most of the trailer designs that we do. And that's pretty typical of most of our trailers. A couple things we've learned, especially with utilities, their fleet groups have their own standards for what they expect from trailer designs in terms of lighting, the placarding, safety features. So we have learned quickly to pay attention to the fleet standards for each of our customers. Like I said, you don't want to get crosswise with the fleet groups. We don't worry so much about arc flash anymore with most of our trailer designs per some recent updates of the NFPA 70E. For systems under 150 volts, there's no need anymore, pretty much with most of our trailers, to provide arc flash calculations, which used to be standard for trailers that we sold. We do recommend, let's see here, tandem axles. We just think that's the way to go. Most of our trailers go out somewhere between 10 and 14,000 pounds. And there you can use, either like a 250, and you don't need special licensing, except that over 10,000 pounds, this GVW, medical examiners is required, and anything over 26,000 pounds, commercial driver's license is required. Not many of our trailers get into that area, but just something to be aware of. Customers really like it when we give them plenty of amenities. These are gang boxes all over the place to accommodate all the stuff that we provide, the wheel chocks, the portable grounding rods. Most of our trailers will pull up. There is an existing ground, but in many cases, in remote locations, they need to be able to ground the trailer. So we've got boxes for tools, for accessories, for all of the equipment, document holders. You can't have enough of those inside the trailer with the drawings and instructions. I was just talking, one person trailer came in and there were no drawings and no instructions how to power and discharge the battery trailer. We try and make sure all of that documentation is there. Some final lessons learned. Every state has different DOT requirements, and if we don't do our homework up front to understand what the state of Connecticut wants or what Nevada wants or what Florida wants, that can make it very challenging for our customers to get those trailers registered. So we do our homework to make sure that we understand each state and their specific requirements. We have learned over the years to extend the length of the hitches. It makes it much easier to maneuver our trailers for the drivers, and also more and more we're mounting generators on those extended tongues for extended power applications. More and more of our customers are asking for pintle hitch designs because they're using larger vehicles to tow these trailers. And lastly, a couple things we've learned. The flooring, very important. We do a really nice job of ruggedizing heavy-duty floors, over the plywood. And we've also learned to now undercoat the bottom side of that because it really prevents a lot of the problems of moisture, dirt, debris from impacting the trailer. It pays dividends. It's little things like that customers appreciate. That we've learned to do. So I'll finish up talking about one trend, very interesting trend that we're seeing with battery trailers, and that is a growing. Customers are starting to send out RFQs for grid scale power on wheels, and that is a very interesting challenge. Okay, we're seeing more and more RFQs asking for it, and these requirements are asking for 1 to 2 megawatt hours of portable battery for grid scale applications on wheels. That is a big battery, okay? You think about the primary use cases, command and control centers for any kind of a disaster, man-made natural disaster, being able to wheel in 2 megawatt hour of power to power command and control. One application that seems to be very popular, large sporting or entertainment events. If you've ever gone to these things, they have these giant generators, 150, 200, 300 feet away. They're noisy, they're loud, fumes, and a maze of cables. It's really a difficult proposition to deploy it. How about we just bring a real nice quiet battery right up to the point of application where you don't have these issues? And really any place where people want to bring grid scale power to any use case application, depending on seasonality, depending on weather, the idea of grid scale power on wheels is really getting very attractive to people. You look at the value prop for that. Great flexibility in terms of where and how you position grid scale power. You can deploy it quickly, get it to a site that's being affected or is down. Think about the operational flexibility that it presents to people instead of one static grid battery, a battery that now you can bring to each use case as needed and bring resiliency and sustainability to almost any application. So I'll leave you with this. These large-scale, grid-scale, or battery trailers do exist now. This is a 2.1 megawatt hour vehicle. They've built 4 or 5 of them, and this thing is a beast. So that's 2.1 megawatt hour of battery. It is in the field. It's being deployed. It's a little heavy, like 88,000 pounds, over the road. But, you can see that they've siloed the batteries, they've siloed the electronics, they've got the total interconnect packages there for rapid, fast deployment of grid scale power. So we think there's a real future for this, and that's all I have to say about battery trailers. So thank you.